Hello, everyone. I'm Xiao-Yang Liu. I'm going to share our interesting observation that tensor networks, and quantum tensor networks in machine learning exhibit an hourglass architecture, thanks to my collaborators Qibing from Tensor Learning Unit Riken Lab and Walid from Lockyer Lab. We attempted to initiate a layered architecture for tensor and tensor networks. It may benefit the development of machine learning theory, AI chip manufacturing, and AI applications. Let's look at those 7 layers. Layer 1, X processing unit. In the post-Moore's law era, the rise of deep learning can be largely credited to a new paradigm, intelligent computing for computational intelligence. The impetus to AI computation is made for AI processors such as GPU, FPGA, ASICs, quantum processor. We call them XPU. Layer 2, BLAS and automatic tensor differentiation. To fully utilize the computation power of XPU in Layer 1, BLAS and AutoDiff are a knife and fork to support effective implementation of machine learning models on the top. Such BLAS standards are implemented and optimized in different programming languages. For example, NumPy in Python, cuBLAS in CUDA. Of particular interest is the automatic differentiation of for tensors and tensor networks. Layer 3, tensor data structure. Tensor is the most popular data structure in machine learning, especially in deep learning. A frequent question would be, why do conventional machine learning algorithms use vectors and matrices, while deep learning algorithms and neural networks mostly rely on tensor? A direct answer is that deep learning usually involves hundreds or even thousands of features. Layer 4, tensor decompositions and tensor networks. There are many kinds of tensor decomposition models, including CP, Tucker, tensor train, tensor ring, tensor decomposition. Hierarchical Tucker, TSVD, reshuffled tensor decomposition, and also their sparse and long negative variants. Tensor networks show advantages mostly in space complexity reduction and computational efficiency. Layer 5, tensor libraries and programming IDE. Widely used tensor IDEs are TensorFlow, PyTorch, TensorRT, also TensorLayer and TensorLay. In physics, there are iTensor, TensorTrace, and Google's tensor networks on TensorFlow. Layer 6, machine learning algorithms and models. There are active research on designing tensor-based machine learning models, including tensor regression. In physics, there are DMRG, TTN, mirror, PEPS algorithms. Layer 7, applications and products. Many products embracing AI is enjoying a booming market, penetrating our daily life from smartphones to self-driving cars and robotics, search engine, typing assistant to healthcare services. Such a 7-layer hourglass stripped layer architecture enjoys discipline advantages, including layer-wise standardization, inter-layer modularity, and interlayer separability. We expect tensor and tensor networks continue to serve as an amplifier for computational intelligence, a transformer for machine learning innovations, and a propel for AI industrialization. A take-home message would be, there is plenty of room at the bottom, in the middle, and at the top. Thank you.